So now this is the last part of our proof technique. We call it proof by contradiction. What does the word contradiction sound like to you?
No.
Contradict. What does that word mean?
It proves itself wrong.
Yeah, exactly. It's like to go against something, like no, to contradict, to go against somebody, to something not right, right? To say, oh no, this is not right, this contradicted, this doesn't go in line with that. Anyway, so when we prove by contradiction, you want to assume something and be able to prove that what you assume doesn't make sense. So if what you assume doesn't make sense, then the opposite of what you assume must have been what you ought to assume. Do you understand? Okay, I'll tell you. Again, look at this. To prove this, first, you are going to assume that, oh, look at, for example, in this case, if this is even, then this is odd. Now, we're going to assume that this is not odd. Okay? And see if we can get if this still makes sense. If this is not odd. If it still makes sense, then maybe this was wrong initially. But if it doesn't make sense, then your assumption must have been wrong. Does that make sense now? So that's the whole idea. So quickly, suppose this, if this happens, then this happens. Then you say, suppose A is even on contrary. This is on contrary. Okay? Suppose A is even on, I need your eyes here, stop looking around. Suppose A is even on contrary, because the statement says A must be odd, right? Oh, what if A is not odd? Let's say A is even. What happens? If A is even, it implies that A equals to K. Agreed? Yes. For some K in what? Z. Yes? So if that is the case, let's see what happens here. This implies that A squared minus 2A plus 7 must be 2K squared, right? Minus 2K, no, 2K plus 7, yes? And this will be what? 4K squared minus 4K plus 7. How does it lead to contradiction? Quickly, fast, think fast. You have to be able to get something that is absurd. That's what? Odd. Why do you think it's odd?
Because if you make 2K as like M, and that will be the previous thing we did.
So there will be a plus 1 eventually.
Yeah.
Anyway, the first term is odd or even? Second term? So the sum of these two is what? Even plus odd is what? So this is definitely odd. So it's a contradiction. Does that make sense now? So, is it 1 in? Still 1. Okay, alright. So once you get to this point, you can show us why it is even by going further. So what I would do is this. I will say, I can put it in this form, that, oh, okay, this is going to be 4, okay, maybe I write here, 4K squared plus minus 4K plus 6 plus 1. You agree? Then I have what? 2 brackets, yes? 2K squared minus 2K plus 3 plus 1. And this is the format of what? An odd number. Then you say, which is odd. Okay? Then you say, hence, we have a contradiction. Or which is a contradiction. Hence, we have a contradiction. We have a contradiction. Now, what is the assumption that led to this contradiction? A is even. So since this leads to a contradiction, then A must be odd. And that is how the result will come about. So your expectation, you assume, oh, what if my expectation is the other way? If I run into a contradiction, oh, then the required statement is true. Does it make sense? So, since hence we have a contradiction, therefore, A is odd. And that is it. This is how to prove by contradiction. Let's look at the second problem quickly. The second problem says, who can read this? Prove that quickly. Talk. Try to read it.
No.
Yeah, there's a not. Yes, because of that. What is this symbol? I've used it before. Look at your worksheet, the last question. That is the statement I've written.
No positive.
No. Number 19, I'm sorry. Number 19.
No positive integers.
So there are no. So this is, when you write this in mathematics, you read it as there exists. There exists. Or there is. So when you put that, it means there does not exist, or there are no, something like that, depending on how many values you're talking about. Okay? So prove that there are no integer solutions satisfying this problem. It means you can never have integer solutions such that when you substitute, you get 1. Okay? Of course, there are other solutions you can have. Okay? Prove that you can never have integer solutions. So how do you prove by contradiction? What do you think the contrary assumption will be? There are integer solutions. Okay? So the contradiction will be, so we say the proof now. Okay? Suppose there exists, let's say I don't want to use x and y, so we're going to say integers a, b in z, which satisfies, instead of saying which satisfy, you can say such that what? Complete that for me. A squared minus b squared equals 1. So suppose there are integer solutions such that this happens. So if you now run into a contradiction, then it means there are no integer solutions. Does that make sense? So, what do we have here? How can we proceed with this? Anyone?
A plus b times a minus b.
Thank you. A plus b times a minus b equals 1. How do we proceed with this?
It means they're both equal to 1.
What?
They're both equal to 1.
Why do you say that?
Because if any of them are more or less than 1, then it counts equal 1.
Okay, what if this is half and this is 2? What if this is, okay, but this is smaller. So what if this is 2? What if this is 1 over 2 and this is 2? The product will also be equal to 1. Why are you not considering that option?
I don't know.
Anyone, please? This is a serious discussion. Yes.
Oh,
Because they are integers. We already claim A and B are integers. So the only possibility, so if A and B are integers, their sum, is it integer or not?
yes.
This difference, is it integer or not?
Yes.
So if the product of two integers will be 1, the only possibility is that what?
1 and 1.
Either both of them are 1, 1 or... No? What is the other option? Negative 1, negative 1. Negative 1, negative 1 also multiply to give that. Is that you have 1, 1 or negative 1, negative 1? Does that make sense? So this implies that either a plus 1 is a plus b is 1 and a minus b is 1, or a plus b is negative 1 and a minus b is negative 1. Don't pretend like, oh no, but it doesn't make sense. Of course it does. What if you have 1 and 0? Something like that. What if you have negative 1 and 0? Do you understand? So you don't look at how correct it is. As long as you are logical in your approach, just make sure the last one leads to something that doesn't make sense. Alright? Now we have two options. Okay? So this is, we are going to adopt proof by what now? Exhaustion. Because now we are going to exhaust these two possibilities. Okay? So case 1. Case 1 is if a plus b equals 1 and a minus b equals 1. What happens? Talk to me, please. 2a equals 2, which means a equals 1. That makes sense, right? Okay. What about when you subtract or when you substitute?
B equals 0.
So b equals 0, right?
Yes.
A plus B equals 1 implies that 1 plus B equals 1, so B equals 0. So A is 1, B is equal to 0. What is wrong in this? The second value. Why? What is that question?
Because A minus B is not.
I didn't complete this. Look at that question 19 that I put on the board. There exists no what?
Positive.
Positive. I forgot to put the word positive. That is why it is a contradiction. Because B is not positive. Does that make sense? So there is a contradiction here because B is not, because B is not positive. Which is so you just write a statement which is a contradiction since A, B must be greater than 0 as a result of this clause. Does that make sense?
Yes.
So you stop there. You don't have to conclude yet. So you go to case 2. What is case 2? Both are negative, right?
Yes.
So if A plus B is negative 1 and A minus B is negative 1, again, 2A is what? Negative 2, which means A is equal to, you already have a contradiction, right?
Yes.
Even before you work out B.
Yes.
Okay? But you can work out B and C, but you don't even need to proceed, but I will work out B. So A plus B equals negative 1 implies that negative 1 plus B equals negative 1. What does that say about B? B is still 0. In fact, this is a big contradiction because both of them fail,
Yes.
right? Which is also a contradiction. Don't use the word big, I was just emphasizing on that. Okay? Since A, B is greater than 0. And you could see that in this case, neither of them. But in this case, only one of them fails. But the instruction is that both of them must. I think I should have said this.
Okay.
It's a positive integer. So I should have used positive to restrict the sets. Okay? Now that both condition fails, okay? Now you now say, therefore, what happens? There are no positive integer solutions. Because the two conditions the two cases you try to see, you run into what? Contradiction. Then it means your supposition is wrong. Does that make sense? So this is the end of contradiction. Any question? Please ask. Karen.
Don't you write A, B as smaller than 0?
No, I said which is a contradiction since A and B, okay, maybe, alright, since A, B, what I mean, since A and B must be greater than 0. Like this is the instruction of what must happen. Since A and B must be positive. Okay? I wasn't saying that A and B are greater than 0. I'm saying since that is what we must have. Okay? Maybe the way I wrote it. Apologies for that. Any questions?
No.
Questions? Alright, so this is where we